one that they cut back on as well. So next year we're going to have to try to find another place where we get them.
We'll have to double the cost
Yeah.
to make up for last
It's a lot of pies. We buy like almost 600 pies.
We're not going to bake them up.
Yeah, no, we get like 600 of them. Was everybody okay with this one? You need to tell me if there's any problems or questions, or if I can come over and take a look at what you have. Otherwise, I'm going to assume you're good. These that work out, that when they work out nicely, they usually, you know, oh, they must be good. Okay, here was another one. Make sure, again, you give me your let statements. I'm going to scroll down to the answers. Here's your answers. 20,000, 30,000, 40,000. Just make sure you check your equations and make sure that they're good. Remember, the amount invested is the plain old X. The investment that you make, the income from your investment, is the one with the 0.05, 0.07, 0.09. And you could, whenever one exceeds the other, you could do it on either side of the equation. More importantly, when you come back here, make sure they line up. Make sure before you're going to line them that they actually line up. And there's a number of ways to do these if you did it something different. Matched them up a little differently. Yes.
So I did this before I got one of them, and then I did this. For some reason I couldn't get a good answer.
So which one did you get? 40,000?
Yeah.
And then where did you go with this?
And then I went over.
To here. So the 0.07. 40,000 and 40,000 is 3,600. And you have what? It looks like that's right. Okay. You know, they're selling tickets, they're selling magazines. If you did X plus 3 equals Y, that's fine.
Oh, I did different variables for different.
That's fine. You can use whatever variables you like as long as you tell me in your let statement. And even at the end, if you put them in the order of the way you your alphabetical order, you can even leave it to me this way.
I just do like lowest to highest.
Whatever works for you. That's why you set up a let statement. If you substitute this in, now you have two equations, two variables. And then you can combine your two equations, two variables. Substitute, that worked out a nice substitution problem. There's a number of ways you can do this. Just, like I said, follow yours through, and if you can't follow it, call me over. Good? Okay, I'm assuming they're good. Okay, again, investments.
I had trouble with this one.
Okay. The let statements, the equations. I wasn't fond of the way this was worded either. The $500,000 into his 3 accounts, that makes a nice equation. It placed in one account the 5.5, then 3 times as much in government bonds of that X value is what they're saying. From that short-term one, the short-term times 3 gives you your government bonds. It was weird the way they worded it into the same statement. So once you get your X times 3 is your Y. And that's the amount he put in, he invested.
Can we not have something this worded like this tomorrow?
I wasn't fond of this wording either, but it kind of flows a little bit. What he placed in one, then he took 3 times as much as that one and placed it in the second one. And then the remainder went into your Z. I didn't give you one of these. I didn't give you this something this weird. You know, I like when they do it separate so you actually can see your 3 statements. And I think that's usually what everybody looks for, 3 different sentences, 3 different statements. This just had two in one statement. If you missed this one, it was hard to get the rest because then you only had two equations, two variables. Once it went though, it didn't go too badly.
That's the wrong equation.
Okay, let me jump to the answers. 100,000, 100,000, 300,000.
Which one's 3,000 and why?
My 7% was 300,000. And the one important thing to do with this is make sure your work is organized. It's so hard to go back to these if you don't have a good flow to it. Try to keep your original equations together so you can always go back and look at your original equations. And then as you make your substitutions, if you can label it, something to tell you, well, I was okay up to here, where did I go from here? Oh, there's my second step. Try to keep it as organized as possible because it's very hard, and it's very hard for me to find your mistakes. We good? No? It's always nice when they work out to be these great numbers. And we always think we must be right if they work out nice and evenly. And even in these, if you're buying short-term notes, you're buying bonds, how much did they place into each account? They could place things with decimals in it. They could put in, $3,000.22. So be careful of those. In these guys, with your magazine subscriptions, you have to get whole numbers on these. So how many did they sell? Those have to be whole numbers. Monies can be your investments. You can put any amount of money you like in them. But number of magazine subscriptions, number of tickets, they have to be whole numbers. Okay, here's your peanut mixture. That's key right there, that there's 10 pounds altogether of peanuts, cashews, and raisins. This is the cost per pound. The mixture calls for twice as much peanuts as cashews. There's another one. And the total mixture, here's his total mixture, is $14. Okay, now, the one before this, I think they gave us like the total that we did in the example. The total was like $5 a pound or something. We had to actually multiply it. This time they gave us the amount. We didn't have to multiply anything. Don't multiply that by 10. No questions? Oh. You can always go back and make sure that this makes sense to you. The easiest one, make sure they add up to the 10 pounds. Okay. We have a parabola and a line. A circle and a line. A line can cross a circle once, tangent to it, twice, or not at all. So you could possibly get one solution, two solutions, or no solutions. Remember that every x needs a y. So at the end, when you get your two x's, just because you got two answers, make sure you put your y's to them. Good? Oops. Not good? Questions? Alright, here's a parabola and a line. Again, we could have one solution, two solutions, or no solutions. If you like to set the y equals, that works out really well. I like that when you can y equals, you can also put it in your calculator since it's y equals. Just put it in your calculator and check to make sure that it actually crosses at those points. It's a good check and you don't have to do anything else. I mean, obviously, it's solved algebraically, but it's a good way to check it. Alright. Find the equation. Here's your curve fitting. There's your curve fitting. There's your answers. Remember to put it back into the equation. It says find an equation. And an equation has to say y equals f of x equals, it has to say an equation. And this is nice and checkable too. You can put your answer in your y equals and make sure your 3 points are there on your parabola. Questions at all? Here's another systems of equations. Here's the answers. And you can, it doesn't have to be my way to do this. You could have combined something else, eliminated something else. Like I said, some kids always eliminate X first, some kids always eliminate Z first. Some kids have a little pattern they like to follow. They don't like the Z in there, they get rid of the Z right away, no matter what it costs them to get rid of the Z. Yes. Uh-huh. And you can do it a number of ways. Could have eliminated the Y's easily. Could have eliminated the Z if you like to. One's a negative, one's a positive in them. You could take this equation here. You could take this equation and divide everybody by 2. And start with that. Just like you can multiply by everything, you can divide by everything. So if that works out better, reduce them down. And then your numbers aren't as large. I usually don't up here because then somebody will always say, where'd you get that equation from? So I just always work with the originals, but you can absolutely reduce them down. Good? And then I think, I didn't give you these, I gave you, this is what didn't print out on your paper. I gave you a different one. Do you have it? I wrote one on the board.
Z over x squared minus 14.
Wait, did you give it to us on Friday?
Yeah, I wrote it on the board.
I wasn't here.
Okay.
Z over x squared.
Z?
Or 7. Over
7?
X squared minus 14.
X squared minus
14.
14x. Okay, so let's separate these.
Um,
So how do I factor the denominator?
which one are you doing, 10 or 9?
This one. I gave you this one. This is what was supposed to print out on your paper, but it didn't.
I didn't have any room for packets.
You can put it anywhere. What does this factor into?
5 x minus 14.
So how do I separate this now?
A over x plus b over x minus 14.
Good. And your common denominator, you know what your common denominator is? Multiply everybody by your common denominator. So this becomes 7. What does this guy become? X minus 14 plus bx. Okay, now what? Now what do I do?
So like A would be 14 minus 14.
Okay, so we take both of these and we set them equal to 0. So x would be 14 and x will of course be 0. So first turn through, we'll make x be 14. This is going to eliminate your a. Okay, so this is wiped out. I just did something.
You just did it. Yeah, you just did
I didn't
it.
substitute the 14 in. I'm saying, uh-oh, what did I miss? I was thinking in my head, if you look in the book has, there's more that you can do things with triples. You can even do 4 of these things. However many you get factors of these, you can have A, B, and C. We just keep it to 2 simple ones. Like, just 2 is enough to see that you can separate these. But you can absolutely do these with 3 factors and 3 variables. They just take a little bit longer to go through because remember, once you eliminate one, now you have 2 others you have to eliminate a common one and do it again. It just takes, it's a little bit longer, but you're always not limited to 2. So therefore, what is B equal to? 1/2. Okay, so save your 1/2. Now do your x equals 0. And this is going to wipe out. What is A equal to? Try to keep your negatives the second part so it looks a little bit better. So B is 1/2. I'm sorry. Give myself enough room. And so what do we have to do to this now? What else are we going to have to do? Take the fraction, you change flip, put this over 1, flip this over. So that 2 comes into the denominator. I'm sorry, I'm running out of room everywhere here. So it's just 1 over, don't lose your 1. And it's got to be equal to the original. Okay? Make sure you don't leave me a fraction. You can't have a compound fraction in an equation. Okay. Would you guys like to try the other ones that are up there? Do those? Do one of them? I have once you get your equation at the end, put the first part into y1. Didn't you guys ever learn to check like y1s and y2s to make sure they're the same with an equal sign? No. Okay. Look. Okay.
Oh.
No, please. She said both of her factors equal to 0.
Oh, I see.
No, you're good. You're good. You're good.
Oh,
Yeah, no,
I was writing.
I do too. Sometimes I move over too far. Now she's substituting in the other one, which will wipe out the other factor.
Oh no. Ah!
Yeah, it happens when you hit that. I know. Let me see if I can move this back down.
Oh wait. Sorry.
No, you're fine. It happens all the time. Yeah. Just continue.
You get what that
Yes,
is.
we get that. Sport is tricky.
just a catch.
Very good. Now, if you wanted to check it, easy way is just to put this piece right here in your Y1 and put this piece here in your Y2. Just when you graph it, it doesn't matter what the graph looks like. Just look at your table and make sure they're the same values. And you know you're right. It's a nice way just to break down your equations and check them. It's an equal sign. They have to be the same thing on both sides. Good with these?
Yeah.